In this session, we'll talk about how we really operate the text strings, the text related data, the characters, and how do we really get into the different kinds of pattern matching associated with the text. So, all these manipulations in R is what we are going to look at now. So, for that, let me first create a simple variable, char variable. I'm just saying I'm creating a vector of character variables, right? Initially, I am creating it as probably I'm creating it as a set of variables saying okay R is an excellent language for data analysis. So I'm creating some such kind of a set of character variables. R is an excellent language for data analytics. This is what I'm calling it as a set of character variables. Now just let's see what is the class of this character variable. For char, if I'm seeing it's a character, which means it's a string category. Now what all things I can do on this string? The first thing, I can find the length. So let's find out the length of char. So it is saying 8. What does this 8 mean? There are 8 different elements. R is one element. Is one element. An is other element. Excellent is other element. So it goes like this. So there are 8 such elements which are characters which are assigned to a variable called char. Then if I want to know how many individual characters are there for each of the entries. So R means there is only one character. Is there are two characters. And there are two characters. So like that, if I really want to find out how many characters are there within each of the element, I'll use nchar. Nchar is nothing but number of characters. The number of characters for this character vector. So what it is saying? 1. The first one is having one character. The second one has 2. Then the third one has 2. The fourth one has 9. And so on. So that is one thing that I want to find out. How many characters are there? So we can find out using nchar. Similarly, if I want to find out what is the type of that particular vector, we can use class which we have got it as character. Now, if I want to convert the vector into a data frame, so this is where what I can do, I'll create a variable called df where I'll say data.frame of my character name. So char I'm converting char into a data frame. Now look at what is the class of df. The class of this df is data frame. And how is the value of the df displayed? Just click df. You get the char. So each one comes in a different row. R is an excellent language for data analytics. So if I want to convert any of my vectors into a data frame, all I have to do is data.frame of that particular variable. Right? Now just check for your original vector, right? In your origin, when you are using char-var, just check, is it a factor? Is factor char-var? Is dot factor char-var? I'm getting it as false. But if you look at it with respect to data frame, is dot factor, when you are accessing the data frame, first give the name of the data frame df and a dollar, and then give the name of the column char-var. Now let's see if this is a factor. Yes, this is the difference. If you are using a character in the context of a data frame automatically converts the characters into factors. So that's one important thing that we have to remember. Data frame by default will convert any column that is having a character values into factors. Now, there are a couple of inbuilt functions that are there in with respect to characters. Now let's type simply letters. Sorry, simple letters. So simply letters, if you type, I get something A to Z, all in lowercase. Even I am typing letters as a lowercase. But if I type letters as uppercase, I get all in the uppercase letters. So these are some default stuff that are there, right? And see one thing more, letters, and within that I want to get a subset, let's say 3 to 5. So I'll get the 3 to 5 letters which are C, D, E. So letters by default is a vector, and I can get the subset of the vector by using a string by using the subsets by using the square bracket kind of a notation. And now we also have seen here, when the output is coming in the form of letters here, it's coming in the form of double quotes. Now I really want to remove that double quote, I can use no quote. No quote if I am using, I'll not get that double quote. See, no quote of letters. So I'll get simply the letters A to Z. No quote capital letters. I'll get them without any quote. So that's one more thing that we can do. Now, the next thing that we can think of doing is the amalgamation. When I combine two vectors, let's say here we had only one vector, so let me create two vectors. Probably let me call it vector 1, right? Or one of them I'll use the above one itself. R is an excellent language. We have already used as character 1, char-var. So right now I'll use it as a vector 1. R solves many business problems, right? I'll say R solves many business problems. So this is another vector that I want to use. Now if I want to combine these two things, I can simply say C of char-var, which is one vector containing characters, and vector 1, that's another vector that is containing characters. Now you see it's a big list that you're getting. R is an excellent language for data analytics. R solves many business problems. So that's the kind of amalgamation that you can do. But let's say you have two strings and you want to separate them. Let's say I'm talking about two strings. So string 1, right? Let's say we'll do this way. I'm creating string 1 with a simple variable ABC, right? Just for us to understand. Similarly, I am creating string 2 with DEF. So let's say these are two strings that I have. If I am using C function saying string 1 comma string 2, the output comes like this. ABC comes with a space, DEF comes. But if I really want to concatenate the two strings separated by whatever separator I want to give. Let's say I want ABC underscore DEF, or I want ABC without anything DEF. So I have two strings, I want to join them using an appropriate separator. Then I'll use the expression called paste by giving what is the separator. If I don't give the separator, it means it will take blank as the separator. Let's use different variants of paste. By default, I'm simply saying string 1 comma string 2. Right? We'll simply say string 1 comma string 2. Then it becomes ABC space DEF. But at the same time, string 1 comma string 2 sep is equal to, let's say I put underscore. So this becomes ABC underscore DEF. And at the same time, let's say I don't put anything, just put a blank, which is like two quotes, two double quotes. It becomes, all of them become merged. So that's one more thing. A paste as a function really helps us in terms of an implementation. Now, the next thing that we are looking at is substring. I have a big phrase. We already had phrases here, right? A sentence kind of thing we have. And all I want to bring out is a substring of that. So where I have to mention where is that going to begin and where what are the number of characters I need to extract. So if I'm saying substring, right? Let's say I'll use vector 1, which was our character, which was our series of characters, vector 1. And no, we will create one phrase completely. It's not a phrase; they are a set of different words. So probably let me do that and start at 1 and 2 characters to be extracted. Now in each one of them, it starts at 1 and it extracts 2 characters. So if you look at R solves many business problems. So because R is only a 1 character word, it is pulling out just R. Because solves is a 6 character word, it is pulling the first 2 characters. Because it is saying starting at the first, it has to pull out 2 characters from there. So solves, SO is coming, many, MA is coming, business, BU is coming, and PR, problems, from problems, PR is coming. So that is how a substring operates. Again, just to repeat some of the things, don't start from the first character, start from the second character and pull out 3 characters. Now because in R there is no second character, nothing is pulled out. And when you are looking at solves, it starts at O and it is ending at the third one, which is L. Similarly, many, it's starting at 2, which is A, and it is ending at the third character, which is N. The same logic, instead of 3, if you make it 4, you'll get 3 letter words because it's starting at the second character and then it's ending at the fourth character. So that is what is being displayed when we are using the substring as a function. In some cases, I may want to use the substring for denoting a simplified version of the various characters. Then, yeah, this is a very interesting function. String split. Right? Let's create, for this to understand this, it's better that I create one complete string. Right? So probably I'll say again string str1. So I'll create only one single string saying R is helpful for analysts. I'm not separating the words. R is helpful for analysts. That's the name of the string that I have created. Now I want to cut each letter separately. Right? I want each letter separately. So which means I want R, I, S, R is some such kind of breakup I require. All letters need to be separated. Now this is where I'm using my vector or I'm using my phrase and I'm saying split is character 0. So split the characters into the individual characters. If I'm using that, when I'm using string split, the string split is nothing but based on whatever thing it observes. So if you want to find the words, if you want to separate each word, what is that I'll do? I'll say string split from this string 1, split based on the space. Wherever you find the space, split it as a separate word. Now you could see it has split. R is separate, is separate, helpful is separate, for is separate, analyst is separate. But at the same time, instead of putting this, if you say character of 0, which means it will put letter wise there is a break. R is, so there is a space. After R there is a space. I, S, again space. H, E. So like this, it splits each of the characters. So it splits based on each character. So if at all I want to get a split of each of these characters, probably the good thing is if I want to identify how many alphabets, how many letters are there in each one. What I could have done, I could have simply used this. This entire thing I could have assigned it to some A as a variable. And I'll simply use my table function to tabulate this entire A. So it says space, there are 4 spaces, there are 2 A's, 1 E, 2 F's, right, 1 H, 3 L's. So I'll get a clear cut tabular representation of how much of each of these things are there in each of my words. So I get the counting the number of occurrences of each character in this full phrase. Even those kind of computations can quite comfortably be done once you use your string split kind of a command. Then, yeah, this is what I have done. And probably even you want to find out, right, how many words of each kind are there and how many different lengths are there. Probably, let me bring one more out. So we have done the string split, right, not the character 0, 1. Okay, we have done this where we have split based on the space. Let me allocate this to B. Now what I really want to do is, I want to, once I have split it, this is what I have done. On that I want to simply apply the number of characters. So for each, see now we know what is B. So for each level I want to apply the number of characters. So this is where we can say lapply, because at each individual list it applies. So probably I could have taken B and I say ncat. For each one of them it counts and tells me the number of characters, right, because it's taking a list out of this, right. And ncar, once I have gone for each of the elements as a part of the ncar, I could have gone on the top of it the table, so which will tell me each one of them each one of them, how many times it has occurred. So one word, one letter word, there is one. Two letter word, there are two. Three letter words, there is one. Seven letter word, there is one, and eight letter word, there is one. So that's one way I can very well count the number of words of different lengths that are there in my data. So that's one more application which we can very well use with the text related functions. Then we have two important functions which can help me to convert my data to uppercase and lowercase. Look at it, right? If you say to upper and you give something vector 1 as the input, right? To upper vector 1, everything becomes in capital letters, right? And probably I could have given a name to that to upper. So probably I'll create that to upper and probably let me give a name called C, so that now I want to convert everything to lower. If I'm seeing C, this is what it is. Then I see to lower and I put C as the input. It directly becomes everything into a lower cat. So these two will help me in terms of doing that activity. Then comes a very interesting part, match, right? So I'm giving a match between the first and the second. So let me do this. Probably we have the first word, the first set of, we'll create two phrases. So this one anyhow we have created. What is the name for it? R is helpful for analysis, right? str1, and I'll give one more called str2. Every analyst should learn R. So this is okay. So I just need to take this out. Every analyst should learn R. Right? Now I want to use match string 1 comma string 2. It is saying NA. Why? There is nothing that is matching. It is doing a word to word match, right? Especially if I am having, it's not, it should be a matching of the vectors. So if you do it not on the phrases but on the vectors, let's say we have Karwar as one vector and we also have created another vector which is vector 1. Let's see if we can find the match there. Match vector 1 comma Karwar. Now here it is saying the first one is a match, right? The first one is a match, so it will look for the second one. First it goes like this. So it looks R solves many business problems. R, is it there in the first? Yes, it's the first word. So that's where it has given 1. Solves, it does not find solves here. Many, it is not found here. Business, again it's not found here. Right? So that is where it has given NA for all the other 4. To best understand, okay, let me take two vectors A, B, C and D. There are 4 vectors here, 4 elements of the vector, right? And we have X as another vector where I'm having B, D, F and A, E. Let's say this is how I have my second vector. Now I do match a comma x. Now if you see here, when I'm saying match a comma x, a is being looked at, right? Here when I'm saying match a comma x, a, it's in the fourth, b, it's in the second, c, it's nowhere, d, it's in the second. So that's where these numbers are getting written. Similarly, let's go now the other way. Match x comma a. Now what is happening? B, it's in, so whichever is the first one, so now you could see B is present in the second location. Similarly, 4, D, it's present in the fourth location. F, it's not present. So what it is doing, it will take this vector first, the first vector. Each element, it sees where it is present in the second vector. If it is present, it retrieves the location of that. If it is not present, it gives NA. So that's how the match function works. So it's another interesting function when we are working with strings. Then the other thing is grep. Especially when I am trying to look for a single, let's say I'm looking at a data frame, right? So let me read through one of the tables. So let me take a data, right? I have it, so let me go with read.table. I have in one of my folders, I have it as E:, our course world flora .txt. I think this is the name, otherwise I'll go back and check it. Okay, I have to do it twice. Okay, so this is not there. Let me just check the name of the file. Okay, it is worldfloras.txt. Okay, so I have data which is containing worldfloras.txt. So if I look at the data, it's containing a lot of stuff. So better let's look at the head of it to understand the data fully. So it's talking of country name, the latitude, the area, the population. Now we are seeing that the headings, because we did not display header equal to T, are true. That's where V1, V2, V3 are showing. So better let's bring in this one more stuff where we are saying that it is having the header which is equal to true. Now when I look at the head of data, will not have V1, V2, V3. The headings are country, latitude, area, population, etc. Now what I really want to look at is, if you look at the class of, what is the name of this data? Data is the name of this data frame. Within that, if I want to look at the class of country, it says it's a factor. So I'll try to convert it into a character, right? So I'll try to convert. So I'm attaching the data. Now, because I have attached, I'll even convert. So what is that I do? as dot character data country, data $country. So I have converted all these things into characters now. Now what is that I want to see? I really want to find out all those that are starting with, or all those that have a capital R in them. So I will simply use grep. Probably the best thing is this as dot character data of country. Let me give it to uh, CTRY, some name, country. So CTRY is the country which is converted into character from the data frame. Now all I want to do is, I want to do a grep. Grep is nothing but search. Search for capital R in CTRY. Now it is saying, oh, 27th contains a capital R. What is that 27th? Yes, Central African Republic. So it contains a capital R. 34th, Costa Rica. It contains a capital R. So like that it is showing those countries which contain capital R. That's a good thing. Now I really want to see, no, it's not that way. I want only those countries which start with R. So if I want to start with some specific letter, instead of just typing in R, I am putting a power sign before it. All else remaining the same, here I am putting a power sign before it, which will give me that only 118, 119, 120th elements contain that. So it is like Reunion, Romania and Rwanda. These are the only three countries that contain capital R as a beginning letter. Now similarly, if I want to search that particular characters which are ending with something, then the way we represent that is that letter and ending is dollar. Beginning is a power and ending is a dollar. So here what I do, I'll remove this, and let's say I want ending with Y, I'll make this. Now 63rd country. Now it's better if I really want to know the names of the countries, better you put what is that name of the country, or now that I have given CTRY, I'll simply give CTRY and the subscript I'll give this grep. Now it gives me the names of the countries at least. Hungary, Italy, Norway, these are the ones that are ending up with Y. So we can find those countries which are ending up with those strings that are ending up with some letter. Then another interesting thing, I want those countries which are ending up which have Y as the second letter, not as the first letter. First letter is, we'll put a power symbol, but as a second letter if I want, this is an interesting part. So where I can simply use the same statement, but instead of something like this, I'll put it as dot Y. The dot, it is starting. So starting is the symbol will still remain same. That is what is an indication of starting, and I put dot Y, which will talk about the second letter being Y, Cyprus and Syria. Now how do I handle the third letter being Y? One more dot. So dot dot Y, anything Y. So Egypt, Guyana, Seychelles. So those are the ones that have third letter as Y. Now what do I do? If I need, let's say, sixth letter as Y, I can put 5 dots, fair enough, but that is where I may fail. So that's where what we do is we put 1 dot, but we put curly bracket, put 5 in it, saying 5 such kind of dots are there. So 5 such kind of dots, and after that there is a Y. So the sixth letter being Y, we have Norway, Sicily, Turkey kind of letters, where the sixth character is Y. Now, another important step. I want to know those kind of countries which have 5 or fewer characters. Right? The countries whose names have 5 or less than 5 kind of characters. So that is where what I simply do is I repeat the same, but here all I am saying is from 0 to 5. from 0 to 5, and I don't need to put from 0 to 5, and I don't need y here, I'll say dollar. So it's as good as saying there are dots, 0 to 5 dots are there. So the dots could be anywhere from 0 to 5, and after that there is a end. Dollar means it's ending. So there could be any 5 dots, and after that there is an ending. So that is what will give me the number of characters which are between 0 and 5. 0 dot, it's giving 6. Okay, I don't need dot, and it could be anywhere between 1 to 5. So let me reduce it. If I make it 4, I get only 5 letter word. Okay, so that's where I can make it 4 to get only the 5 and below kind of letter. What if I remove this dot here? So then all the other countries are coming out. So I'm having the dot, but dot and 4-5 countries and then a dollar. So it's giving me 5 letter characters. So that's the way. 5 and below, if I want, I can give it in this way. So probably yeah, here it is like if I want 5 or below, I'll use comma 4. Now similarly, if I want anywhere 15 and above, so in this what you set is first set 15. So first 15 are any characters, but after that again first 15, and after that there are any more 15 to any number of dots are required. So any 15 to any number of dots and then ending. So this is where you get all the big names which are having characters above 50. So all these kind of grep related functions really help us in trying to find out the specific number of characters, and based on those trying to identify those letters which are associated with specific number of characters like this. Right, lot of string functions will help us in dealing with these kind of aspects quite comfortably. Then if I really want to replace some such kind of stuff, so basically replacing one with the other, right? So let's say I have vector 1, just recollecting it. I had this vector 1, and so now if I want to replace, let's say capital S with small s, right? So I want to replace capital S with small s wherever it is, or probably is there any other letter that we are having more, or small s, let me replace it with capital S. Now this is where I'll do G sub, right? G sub. So what is my source? Small s. What is my target? Capital S. And what is the set of text or the vector where I want to do it? Vector 1. Now if you see, yes, the small s got replaced with capital S. This, wherever small s is there, it got replaced with capital S. Now this is the G sub. But at the same time I have one more which is going somewhere like this, right? Or use sub, yeah, not G sub. Go with the sub. For the same thing, instead of G sub, you use sub. Everything remains the same, right? In the vector 1, instead of G sub, I'm simply using sub. What is the difference I note? Okay, here there is no difference. This S got replaced the same way. Here also there is nothing. But this is where the problem is. Here you see the 3 small s's are there. All 3 of them are converted into capital S. Whereas here you are seeing only the first one getting converted, the remaining two remaining the same. That is the difference between the sub and G sub. G sub, the conversion happens for all, whereas in simple sub, it's only the first occurrence of the element that would be substituted. Whereas in G sub, everything will be substituted. Right? And there is one more interesting thing which checks for a particular expression in a text. If at all it is found, it shows where it is found. So especially here, let's say I want to find out where a small s is present in the vector 1. I'll say a reg expression and I'll say small s comma vector 1. For vector 1, in vector 1, where is small s present? Now a few things you could see. In the first one, there is no small s. That's the reason it is showing -1. Whereas in the second one, the small s is present as the sixth character. So that's where 6. In the third, in many, there is no small s, so -1. In business, the first occurrence of small s is the third character. So that's where it is showing 3. And again, in this one, the 8th character contains small s. That is what it is showing. So that is what your reg expression is going to do. It tries to find out wherever, whatever you want to search. Let's say I want to search double S. You don't need to restrict yourself just for one letter or something. Let's say even a string, a set of characters you can still use. When you are doing double S, you see here in the first 3 there is no double S, but the 4th one contains double S starting from the 7th location, business. So starting from the 7th location that there is a double S, so that's the reason it is giving me a value associated to that. Then there is one more interesting thing called char match, a character getting matched. If that character is present at multiple locations, then it might give a 0. But if it is, let's say I want to do a char match of M within this vector 1. I want to see a character match of M. It says third location. The third word contains M. But do the same with S, because only M is present only in the third word. No other word contains M. But now instead of M, search for S. It says NA. Because there are so many words that are containing S. But look at double S. Now it's only the starting one. Index of the match if there is a unique match. Okay, SS there is a unique match, but yeah, it has to be with a starting. Only character, one single character is matched here. So if I am giving capital S, yes, it is doing 2. Or probably let me give, yeah, it has to be the starting letter itself. So if I am giving B, it is saying NA. Okay, it has to be capital B. So instead of small b, let me give capital B. It says in the 4th word it is present. So character match is doing this. And similarly, I can very well talk about a which finds out the location in the first named vector of all the entries that are there in the second named vector. We have already seen that. So it's a different way of finding out. So I can say which we have already used earlier to get the locations match. So the same thing I can do str1. I have used str1 and str2 earlier. So str1 percentage in percentage str2. If I am doing it, oh, we didn't use those. What are the words that we have used to compare? Let me just go back. Yeah, X and A. Sorry. So let me use X and A, which X percentage in percentage A. Now it's saying if I'm looking at X and looking at in A, so it's a better version of this match. Right, in match we are getting 2, 4, 1 in this way and some NAs also, whereas here it is giving me which locations of A are also there in B. If they are not there, they are not even shown as a part of NA as well. So what we understand is we can use different kinds of text related functions, we can manipulate the data, and we can really do lots of logics and computations whenever we are encountering our text related data. Right, all this is very much important when we are trying to do different kinds of analysis on our data. Right, so if you have any further queries regarding this, you can very well get back to me by giving me a call on the number that I have given below, or you can send in an email at vamsidhar@pacegurus.com. Thanks a lot for listening to this session. Thank you very much.